Hi students, welcome to HSC Earth and Environmental Science and Module 7 Climate Science. This is video number 13 and the second last of our little mini-series on recent climate variations. This time we're going to talk a little bit about instrumental records. As with the previous ones, we are identifying and explaining some of the more recent evidence of climate variation. This time we're going to be focusing a little bit more on human instrumental records. So there's a lot of different ways of recording information about climate change. Some of them are indirect ways, and we've seen some of that. We've been able to read some of the patterns of climate influence on things like the growth of plants. We've looked at how some of the ancient atmosphere can be trapped in ice, and then we can release that at some stage later and analyze that to see what sort of composition we have in the ice. We can also look at paintings from indigenous people from many years ago to see how the environments around them may have changed over time, or at least what's been happening in that local area, what sort of characteristic plants and animals might have been present many years in the past. But in terms of actual measurement, using instruments to record particular values, well, that has a much shorter history. So in terms of recent, this is very recent. We think that measurement of climate probably only goes back a couple of 100 years, and specifically really only about the last 130. We've got a lot of anecdotal evidence, some of that in the landscape arts, some of those obviously go a little bit further back than this kind of key idea that we had, but there's probably maybe about 300 years is our best continuous record of any, and that's in England that we've got some of those continuous records. What we have been able to do, though, is where we've had data from some significant period of time, we've actually been able to make specific measurements for some period of time. We've correlated that with some of the things that we've already looked at. So we've looked at ice core data, for example. We've looked at dendrochronology, and we've seen if there's ways we can analyze tree rings or ice core data and see if we can track some of the changes in the environment over time, specifically any changes in the climate over time. And so if we've got records that go back for a certain period of time, then we can again use these as a form of correlation. So what we're trying to do is to link each of the pieces of data that we have, bring them all together so that we can then think through them, see how well they line up, and feel more confidence in the validity of our data sets. And of course, validity is one of these key terms that's very important in a science course. And validity is about being right, I guess, or being true in a certain sense. What we want to make sure is that the data that we're collecting from ice, from tree rings, from instrumental records, from Aboriginal cave paintings, are all telling us a similar story. If they're all telling us different stories, then we would be questioning the validity of our data sets. But if they line up, if there's a way where we can see that the information that we're getting is telling us a consistent picture, then we can have more confidence in the data that we're collecting. So modern weather stations look a lot different to some of those collection devices or instrumentation that was present over 100 years ago. Now, through the beauty of computers, we've been able to miniaturize a lot of these, make them far more portable, make them far more accurate, and also make them often very multi-purpose. So recent climate change that we've been able to identify has come through the analysis of instrument records that includes a range of different types of quantities. These include things like temperature, and temperature involves both air temperatures, surface temperatures above the water, maybe average ocean temperatures, and a lot of these do come down to maxima and minima, and also averages. We've also looked at precipitation, the types, the amounts, the nature of that precipitation, where it's actually falling, and correlating that with things like latitudes, for example. We've looked at humidity, which is obviously the amount of water in the atmosphere. We've looked at wind, speed, and direction. We've looked at the amount of radiation that's changing over time, and we've linked some of that into our Milankovitch cycles. And we've also looked at things like atmospheric pressure and how changes in atmospheric pressure can give us an indication of maybe a warm or a cool change that are on their way. Remember, the thing with weather and climate is the scale. That's the key difference between weather and climate. So weather's giving us a series of data sets day by day. What we want to do when we want to convert that data into climate data is we have to start looking for patterns, and we see if we can find some overall patterns that help to tell us a bit of a story. One of these kind of instrumental sets that we can look at, and probably the most useful one, is temperatures. Now we can talk about rainfall and a few others, and we'll do some of this in class. But temperature is a really important one in terms of, I guess, the fact that our temperature records are the ones that go back probably the furthest. Being able to identify surface air temperatures extends back through not just into the middle part of the 19th century, but there's some aspects of records that we know from England that are probably about the oldest continuous records extending for over 300 years. Recent observations of surface ocean temperatures provide a picture of the global average surface temperature, and often what we're trying to do is we're looking at averages, and you can see from the graph over here that there's a plot of annual mean temperatures for each year and also a 5-year running mean. So looking at the last 5 years, so obviously we're not going to get any values until 5 years starts to appear. And what this does is it smooths the curve. So we're getting a smoothing of our curve, which allows us to, I guess, interpret the overall trend a little more easily. Remember, one of the things about graphing is we want you to try and draw information out of graphs. We want you to try and look at graphs like this and see what information it's telling you. And so one of the key things is that we're looking for trends. Do we have an uptrend, a downtrend, a horizontal trend, or do we have no trend at all? Is there no relationship between the data? So you're always looking for some sort of pattern in the data. Now, if your mathematics is strong, you might be able to think about the sort of mathematical relationship that might exist when you're looking at a data set being graphed onto a grid like this, but that's not always easy or obvious, and it's not necessarily critical either. It's just one of those things that might actually help you to make more sense of the relationship between the horizontal or x variable, which is time in this situation, and the y, or often dependent variable, which is the temperature anomaly. So you can see some changes that are occurring here. And always look too at the scale. So this looks like a big temperature change, but actually we've only got a range of temperature anomalies of 1 degree in this sort of a range. So it's easy to make data say lots of different things, so we need to be very sensible and critical when we're looking at data and drawing our conclusions from this data. Most of the time with temperature, we talk about maxima and minima temperatures, and you often find that if you ever turn the news on in the evenings when they're doing the weather reports, they'll tell you about the expected maximum temperature for tomorrow and the expected minimum temperatures, and usually we also are looking at average temperatures, and they're the ones that we tend to plot over time. This gives us some good data around about the fluctuations that can occur day by day and season by season, but also year by year. The analysis of temperature, generally in speaking, involves the calculation of averages and identification using mathematical techniques of periodic variations and trends, which may be revealing evidence of climate change. So what we want to do with this data is we want to sort of work backwards in time to see if we can see any trends, any patterns that are occurring. And then obviously one of the things we want to do if we do identify a trend is see if we can explain what's going on with that trend. It's one of the reasons data analysis is such a critical part of the Earth and Environmental Science course, and especially in regards to climate science. There's lots of data around, and part of what we want to do is to take some of this data, have a look at it, analyze it, see if we can work out what's going on and reasonably understand what it's telling us in terms of recent climate variations. So this is obviously something that we're going to be having a little bit more of a look at in class as we try and gain some experience and skill in analyzing data sets, including graphical data. Thanks for watching.